Okay, this is your second question. Now this is for the homework portal, week number 7. Okay, let us begin with this. This is for IB1 student for a change. As I told you already, we will have problems related to electricity, magnetism, and in fact it includes electrostatics and also fields. Since we are describing about electric field, I thought gravitational field will also be a better one to discuss about it because it comes in the chapter on fields. Okay, now let us start with this. The diagram shows this was 6 marks. So let me start the timer also. I thought initially we will not have, in the last video I told you about it, but then I thought, okay, we are taking a very long time and having a timer would limit my way of talking to you people more. Okay, so the diagram shows field lines for the electrostatic field. X and Y are 2 points on the same field line. Okay, there are 2 points on the same field line. Now, one of the outline, which of the 2 points has a larger electric potential? To understand the electric potential in the electric field, first look at the arrows in the electric field. The arrows is directed like this. So when can an electric field have directed like this, arrows like this? If this point is a positive charge. This point is a positive charge and this point could be a negative charge. Definitely the magnitude of this charge will not be this one, or maybe this is negative as compared to the positive charge. Why do I say so? The reason is because, see, when you have a positive Q over here, the electric field will be directed outward like this, okay, with an arrow which is directed outwards. And if you have a negatively charged electric field, which means what? The arrows will be directed towards the charge. On the basis of this one, I have just put plus and minus over here, so that it's easy for us to understand. Now, if I consider this as positive charge, the distance between this positive charge and this one, let me call this as R1, and between this and this two, let me call this as R2 over here, R2 over here. Now, if I ask you what is the potential at this point, the potential at this point Vy is equal to Kq divided by R1, and due to this it is Vx is equal to Kq divided by R2. Let me assume Q is a charge here. Of course, you can always say the potential at this point is not due to one charge, it can be due to multiple charges. Let me consider for time being, okay, there is one charge here, okay, due to this field line. So as a result of this, now which one is larger here? See, R1 is lower, so Vy is definitely larger than Vx. Similarly, if I consider the rest of the charges also, even then Vy due to all the charges will be larger as compared to Vx. So therefore, which has a larger potential? Vy has a larger potential. Vy is greater than Vx. Okay, you can mention this. So how do you mention? You can mention this diagram. You can put all these things. Right. Now let us move on to the next one. A satellite is launched from the surface of the Earth into a circular orbit. The following data is given: mass of the satellite, height of this. Okay, all this is given. Show that the kinetic energy of the satellite in the orbit is about so much. Kinetic energy. What is kinetic energy given by? Half mv naught square. What is v naught? Orbital velocity, right? Half m into what is orbital velocity given by? V naught is equal to root of gm by r, right? So if I square this, I get this as capital gm divided by r. It's not r actually, it's r dash over here, or maybe I'll write this as gmm by 2r. Now let us substitute all the values given here so that I can calculate this value. Now what is g here? G, we know from the data booklet, it is 6.67 into 10 to the power of minus 11. What is m? Mass of the earth. What is mass of the earth? 6 into 10 to the power of 24. What is the mass of the satellite? What is the mass of satellite? 8 into 10 square. 8 into 10 square divided by 2 into, now see, this satellite is not on the surface of the earth. It is at a given altitude. What is the altitude? Height of the orbit above the surface of the earth is 5 into 10 power 5 meters, and radius is equal to so much. So it is like this. This is the earth over here and the satellite is revolving like this over here. So which means you need to consider this total height, which is r plus h over here. That's why I told you r dash, right? So therefore it is r plus h, which should be 6,400 kilometers plus, what is this now? This is height. What is height here? Height, okay, I already have 6.4 in 10 power 6. I need not assume anything here. I'll write this as 6.4 into 10 power 6. And what is the height? Height 8 into, sorry, 5 into 10 power 5 plus 5 into 10 to the power of 5. Okay, so when I do this, so how much do I get? This is 10 power 6. So I can, what I can do is, now let me take the numbers separately. 6.67 into 6 into 8 divided by 2 into this 64 64 plus 5 into 10 to the power of 5. In the numerator I have missed this. 24 plus 2 is 10 square, 26. 26 minus 11 should be 10 to the power of 15. Okay, so now let us do this using my calculator. So it gives me, where is my calculator? It's here, right? So this should be 6.67 into 6 into 8 divided by 2 is equal to so much, divided by 64 plus y is 69. I get the answer is 2.32. So I get the answer is 2.32 into 10 power 15 minus 10 power 5 should be 10 power 10 joules. So which is closer to this value. So we have come to a correct answer. Let us look at the second one. Determine the minimum energy required to launch the satellite. Ignore the original kinetic energy of the satellite due to Earth's rotation. Okay, so minimum energy. See, this is the Earth over here, and what is that you want to do? Now the satellite should be started from here, launched here at this height over here. It should be kept over here. The moment you keep it, what will happen to satellite? Satellite will immediately start falling here. So what you should do? You should not make it fall. It should permanently stay there. So which means you need to give an orbital velocity here. Okay, which means the energy that you require for launching is nothing but your half mv naught square plus now the difference in potential energy, right? If I say I want to lift an object from my palm here to this height, what do? I will say it is mg into h. How do I do it? Mg into h is the final potential energy. Mg into h, mg into 0 is the initial potential energy. I take the difference between these two, right? So therefore I will write delta potential energy here, right? In gravitation we cannot use mgh over here, right? Because the potential energy is assumed to be 0 at infinity and it has a negative potential energy. It's not 0 on the earth over here, right? So now let us write down this equation, which should be half m into what is v naught square? Half mv naught square we already found out here. Where did we find? We have found out here kinetic energy, right? So which is nothing but 2.32 into 10 to the power of 10 plus delta P we have not found. What is delta P? This should be GMM divided by R1 minus GMM divided by R2. Difference in potential energy, right? When I do this, what is it I get? I get this as 2.32 into 10 to the power of 10 plus GMM is common, multiplied by 1 by R1 minus 1 by R2. What is this R1 and R2? R1 is nothing but this distance, which is this 6400, and what is R2? R2 is this one. So when I do this, this should be 2.32. I'll do one thing. I'll just compute this delta P first. I'll substitute here because every time I need to write it, okay, which will be cumbersome, taking more amount of space. I'll just write delta potential energy is equal to 6.67 into 10 to the power of minus 11 into 6 into 10 to the power of 24 into mass of the satellite. What's the mass of the satellite we used? Mass of the satellite 8 into 10 square into 8 into 10 square multiplied by 1 by R1. What is 1 by R1? 1 by 6400 kilometer, which is the radius of the earth. The potential energy here was some value, right? And this is the next potential energy, initial, final here, minus 1 by, what is this height? This height, what is this height here? We got something here, 5 into 10 power 5, which is nothing but 50 or 500 kilometers. 500 kilometers, which would be 6,900 kilometers, right? When I do this, now what is it I get? Let us write down here once again, 6.67 into 6. Let me do all this math first to make it more simplified, right? Otherwise, you know, it will be very difficult for us to calculate the whole thing. Keep on writing again and again. So 6.67 into 6 multiplied by 8 is equal to 320. So I get this as 320 into minus 11 plus 24. 24 minus 11 should be 13. 13 in plus 2 should be 10 to the power of 15. 15 multiplied by, now here I'll do it like this, kilometers here. I'll remove this kilometer outside. This is 10 square also, right? I'll do one thing. I'll write this as 1 by 64 minus 1 by 69. And you have a 10 square here, kilometer here. This should be 10 square kilometer. I'll write it like this. I'll simplify it later on. So which should now be equal to 320 into 10 power 15 divided by 10 square into 10 cube, kilometers 10 cube, so it will be 10 power 5 into, now what will this be? Take the LCM, so 69 minus 64 divided by 64 into 69, right? So when I do this, what is it I get? Let me use my calculator now to make my things faster. So we already crossed 36 minutes, 320. Okay, first let me calculate this value. 69 minus 64 would be 5 divided by 64 divided by 69. So how much do I get? I get the answer 0.0011. Okay, so I'll write this as 320 and 10 power 5, 10 power 15. I'll write this as 10 power 10 multiplied by, what is the answer I got? 0011, right? 0011. Okay, 0.0011. When I do this, what is the answer I get now? So 320 multiply this by 320, I get this as 0.362. 0.362 into 10 to the power of 10. Now what is this now? This is nothing but your delta potential energy. I need to add up with this one here. So this value already, see, this value is 2.32. 2.32 into 10 power 10 plus, what is the answer I got here? I got this is 0.362 into 10 power 10. Wow, the power is same. So 0.362 into 10 power 10. So when I do this, how much do I get? Once again, I will use my calculator so that I don't commit any mistakes. Okay, fine. So let me look at this. 2.32 plus 0.362, I get the answer is 2.682. So 2.68 into 10 to the power of 10. What is the unit over here? Joules over here. Have they asked to prove something? No, the minimum kinetic energy. 2.68, this is nearly 2.7 into 10 to the power of 10 joules. What is my answer scheme say? The answer scheme says 2.7 into 10 power 10 joules. Correct. Okay, thus we have arrived at an answer. Okay, so fine, we have come to an end to this problem. Let us see the rest of the problems from tomorrow onwards. Okay, thank you.